This is the last of our 3 introductory graphs in 4.7 Part 1. We are going to be taking a look at the tangent inverse graph here, which is, of course, again derived from the original, which is y equals tangent of x. In 4.5, we graph tangent. Those details are, something that you can look back to later on if you want to find out what's happening with those. But I want to remind you guys about the fact that tangent and cotangent, they had some vertical asymptotes. And the vertical asymptotes for tangent specifically, they went from this tangent was centered, and so it split the difference on both sides. So what we have here, if we're trying to draw the asymptotes in, it has to have a width of pi for that period, and because that is the period, by the way, of any tangent graph if it's not modified in any way. So the period is pi. That means that those vertical asymptotes have to be pi apart. Now, pi is about 3.14, so half of that on each side is about 1.57. So what we're going to do is notice here that these grids are a little bit expanded here. This is 1, this is 2, so each of these little squares is about 0.5. So I'm going to go just beyond that on this side. This is my vertical asymptote on the right-hand side. And then I've also got a vertical asymptote just slightly beyond negative 1.5 on the left-hand side. Now, these have a distance of pi between them, so the x values that they're at are going to be pi over 2 and negative pi over 2. That's something that I want you to keep in mind once we flip this, because those will have something to do with the new parts to our inverse function instead. So that being the case, let's flip it and see what happens. And we're going to try to figure out what the domain and range are going to be of this one right here. So we've got this red overlay for the tangent function, and I'm going to flip it, which means that the red one is now going to become tangent inverse. Now, we've talked about inverses as far as they flip x and y. They flip over that line y equals x. Well, another thing that they flip is domain and range. Another thing they flip is also vertical asymptotes to horizontal asymptotes. So in this case, here's what happens. We have this pi over 2, this number that's maybe about 1.57. That's our vertical, but then we also are going to have a horizontal at about 1.57 because we flipped that. So here is a horizontal asymptote that goes up to pi over 2. Y equals pi over 2 in that case. And then there's also a negative one, and so there's a negative version down here that's going to be horizontal asymptote on the bottom, where y equals negative pi over 2. What that does is that's going to help us figure out the domain and range for this particular graph. Now you'll notice that I didn't work with the side pieces at all. Those are part of the tangent graph, but those are not going to pass the horizontal line test, and so I didn't bother with them anyway because those would immediately be eliminated had we used it. So what we've got now is just this branch that's going to tell us help us find out the domain and range of this one. This one's different for sure than any of the other graphs that we've seen so far. Let's talk about the domain first. This part's easy. The domain, notice that this one's going over here and it's going over here. It's going to the left and the right forever. So there is no end in sight. It just goes from negative infinity to positive infinity. That is going to be our domain in this case. Our range is going to correspond directly with these two asymptotes. And so our range here, though we get really close, we never quite get to them. So this one we're also going to use rounded brackets. We're going to go from negative pi over 2 to pi over 2. So that's going to make the domain and range of this particular graph. Now, there is one other thing that's going on with this tangent inverse graph, and I'm put it on a new paper so it's a little easier to see. There's a lot of stuff going on here. The other thing that's going to be going on here is there is some end behavior now to this one. The other graphs didn't have end behavior. This one does, because it goes on forever in both directions. So since it's going on forever in both directions, the end behavior, if you remember our notation, it was the limit as x approaches negative infinity of f of x, and then also the limit as x approaches positive infinity of f of x. Now the nice thing about this is it just corresponds directly to the range. The highest y value is pi over 2, the lowest y value is negative pi over 2, and so the limit, as we get further and further to the left, it just gets closer and closer to negative pi over 2. So that's going to be our end behavior on that side. On the right, it gets closer and closer to positive pi over 2. So not only does tangent inverse have a domain and range, but it also has end behavior, which is a little unlike the last two. So that's our final inverse graph. I know it's a lot of stuff to talk about and where all this comes from. It's kind of complicated, but on the next video, I will put it all into one little package for you so that you can see what is the important information that you need to know about these graphs.